Hey guys, welcome to review video number 1. We're going to be talking about history and approaches and research methods in this review video. So my goal for these is just for you to watch so we can go over some of the important topics in that unit that you might have forgotten. So you are welcome to watch, take notes, do whatever you want to do, but I want to make sure that you are watching these so I can hit some of the main topics from these units. So this is the stuff that we hit right at the beginning of the year that we jumped into to kind of build that foundation. And so the goal for these, I'm hoping they're going to be 10 to 15 minutes. I don't want to overload you and just teach you the whole unit again. We're just going to kind of hit on the most important people and the most important topics. So I'll be clicking through some of the slides that I used at the beginning of the year. All of these, of course, can be found on Google Classroom. But I'll share my screen with you so you can see the slides that I'm talking through, and yeah, let's go. So let's talk about the percentage of these topics on the test. So history and approaches is maybe 3 to 4 questions, if that, on the AP test. And with it not even being multiple choice this year, I don't even know if it's going to be included in the FRQ. So I'm going to go over that super fast. And that is stuff that pops up all throughout psychology. So you honestly are probably pretty familiar with it. And then research methods is a much bigger chunk of the test. And usually they have at least one FRQ about research methods. So if you don't remember any of that, like statistical significance, any of that stuff, you want to make sure that you are watching and kind of following along, and maybe go back and review and reorganize your notes after you watch this. Again, I'm not sure what that's going to look like for our current situation with the AP test, but I do know that it's free response, and I would assume that they're probably going to include research methods in there, probably like 95%. So you want to make sure that we're reviewing that. So I'm going to share my screen with you, and then we are going to talk about some stuff. Okay, so if you remember, we have history and approaches, right? It's right here at the beginning of the year. And this is just kind of where we talked through different things. I introduced you to nature versus nurture, which is something that you should be totally familiar with. You should be pretty solid on that. And then I introduced you to different philosophers, and like those ideas with the philosophers kind of led into psychology as we know it. So one guy that you have to remember is Wilhelm Wundt, right? Remember, he is the father of psychology. He had that first laboratory in Germany. He was working on it, and he was kind of the founder of all of that. So you want to make sure you know his name, and then you can kind of go into some of those earlier branches. I wouldn't spend too much time on these, but just know that psychology has evolved over the times, right? So you have structuralism, functionalism, it goes into behaviorism, which is still super present today. And then we have that Gestalt and that psychoanalysis, which is Freud. So as you're kind of looking through the PowerPoint, you can go through and kind of reread some of this if you want to. But the big thing is I just need you to know the approaches and the perspectives from this unit. So obviously we have behaviorism, you know names like Watson and Skinner. Those are pretty popular. You know Freud, we've talked about him a lot, even though a lot of his ideas are discouraged today. And then we get into developmental psychology. So when we were talking about child psychology, education, how you develop through different stages, that's something that you want to make sure that you look at as well. Humanistic psychology, you know these guys by now too. Just want to make sure that you go through and kind of remember that all of these are approaches, right? Behaviorism, humanistic, cognitive, all of these are different approaches. And so if you kind of know the basis behind these, then you should be pretty good to go. So that's really all the time I'm going to spend on history and approaches. Again, we're not even having multiple choice on the AP test. And so I don't know if this is going to be included in your writing at all. But just remember, when I say approaches, it's these different perspectives that we've talked about multiple times in other units. So the majority of this video I want to spend on research methods, because it's really, really important, but it's also really boring. And so I think a lot of us kind of checked out when I was talking to you about research methods, because it's just not super fun, but you have to have it, right? You have to know how to build the experiment. You have to know if it's statistically significant. How do we test for that? You need to know the difference between independent and dependent variable. We have to know all of that stuff. So remember, we are always looking for moles in the experiment, right? We're always trying to see in the research, are there any confounding variables? And if we're conducting an experiment, we want to make sure that there are like no moles at all. So I think y'all are pretty solid on the biases. Remember, hindsight bias is the idea that you knew it all along. If you learn something that kind of makes sense to you and you're like, oh yeah, no, I knew that. You probably didn't. That was hindsight bias. Remember, confirmation bias. This is the idea that we like to test things that we already know are right. We like to confirm that we are right. And then overconfidence bias is we think we can do more than we actually can. And so maybe you saw this in your own quarantine situation where you're like, okay, I'm going to get up and I'm going to do this. I'm going to read this. I'm going to do this. And it's 1:30 and you haven't done any of those things, right? That might be a little overconfidence bias as well. Remember, we have a scientific method for how we answer questions in psychology. We have theories. We have to come up with different hypotheses for those theories. We have to define the certain variables, because if we don't define them, then how are we going to replicate it? And then we have to replicate it. We have to do it over and over and over and over again. And so this is where I kind of introduced different ways to get information descriptively. So we looked at case studies. Remember, case studies are really, really good information. They allow us to kind of look at an individual and see, okay, what happened with them? And can we apply that to different situations? So the main guy that we talked about in this unit was Phineas Gage, right? Where that rod went through his frontal lobe and then his behavior completely changed. They used him as a case study to let us know some information on the frontal lobe and what it does. Naturalistic observation is also a good one, just kind of observing and seeing what is happening, right? This is never going to tell us why, but it's going to let us know, like, hey, I see what is happening when I'm not trying to manipulate or control the situation. And then surveys, right? Taking a particular group of people that's representative of a population and just asking them questions to gather information that way. So this is all ways that we can do research. So I give you some kind of examples and I tell you the pros and cons of those if you want to go back and look at that. We had a lot of fun activities in this unit. So we talked about descriptive techniques, and then I'm going to talk to you about correlations because that was a big thing as well. Remember, we can have positive and negative correlations. Now, correlation does not mean causation, right? We cannot prove causation unless there's an experiment. That's one thing that we have to remember. But you can have things that are kind of linked together through a correlation. It can either be positive, where both variables are moving the same way, either both going up or both going down, or a negative correlation where one variable is increasing while the other is decreasing, right? So you can have positive, negative, and then you can just have no correlation at all. And a scatter plot is always going to be the thing that we use to show correlation. And so if there's no correlation between the two variables, then it's just going to be a crazy graph with a lot of dots, right? There's not going to be either that increasing line or that decreasing line. Now, if we're not using a scatter plot and we're using a number, your correlation coefficient, so the symbol that we're going to use is a little r, a lowercase r, and then you want to make sure when you're talking about your correlation that it always stays between -1 or +1. -1 is a very negative correlation. +1 is a very positive correlation. 0 is no correlation. And then any points like 0.37, 0.65, that's going to indicate positive and negative, and then that's going to tell you the strength of the correlation, right? So this is a little good practice for you to go back over which R value shows the strongest. So this can be positive or negative. We're just seeing which number is the closest to either 1 or -1. And we see that -0.77 is the strongest correlation. It's the strongest, and the negative sign lets you know that it's negative, right? And then which R value is the weakest correlation. So this one would be the one that's closest to 0. So that would be -0.32, right? Because that's the closest to 0 out of all of those. So that's always good. Here's that big thing again. Correlation does not equal causation, because sometimes you can have things that correlate, but that does not mean that they cause each other, like this example here of shark attacks and ice cream sales, right? As ice cream sales go up, that doesn't mean it causes more shark attacks. It just means that those two things are related, probably because you eat more ice cream in the summer, you go to the beach more in the summer, and so therefore you have a more chance of a shark attack. But the only way that we can have cause and effect is if we're doing an experiment, right? And so I'm going to walk you through kind of the different things of an experiment that you need, that you want to make sure that you have. So you always have to have an independent and a dependent variable, right? So the independent variable is controlled by the experimenter. This is the cause variable. And the dependent variable is the one that's predicted, and that's the effect, right? So if you have your hypothesis, eating cookies before class will lead to higher average scores. Eating the cookies itself, that's the independent variable, right? Because we're causing something with that that's controlled by the experimenter. And then that's going to lead to higher test scores, right? So that's the dependent. The scores is dependent on the cookies. So one thing I know that they really like you to do is they'll give you some sort of experiment, and you have to determine what the independent variable is and what the dependent variable is. So you really need to make sure that you're solid on those things. I'll try to maybe find a practice that we can do. But just know, okay, which one is controlled by the experimenter? So what are we bringing in? And then which one is going to be affected by that independent variable, right? That's a really good way to look at it. And then remember, in an experiment, you always have to have two groups. Okay, you have to have the experimental group, the group that gets the independent variable. So if you're using this cookie score situation, your experimental group would be the group that gets the cookie, right? They're the experiment group. But then you also have to have a group to compare it to. So you have to have a control group, and they don't get the independent variable. Everything is normal with them. And then you have to make sure that you have at least 20 people in each group. That's actually a pretty small number. They like to do bigger groups for experiments. But if you're trying to do an experiment with 5 people, it's probably not going to be statistically significant. So you have to have an independent variable, dependent variable. You have to have an experiment group and a control group. Those things are so necessary. If there is a problem or a prompt that's talking about those things, you know that you're dealing with an experiment, right? So you just want to make sure that you're aware of that. And then we're trying to eliminate any sort of confounding variable, which is just something that can get in the way, right? So any environmental issues or differences, any expectations, any individual differences. So for example, if I put all of the smart kids in the experiment group and all of the lower achieving kids in the control group, that's a confounding variable, right? They need to be random to avoid that bias. So we want to make sure that in experiments, we're using random assignment. So you have two different randoms, right? You've got random sampling, and that's used in surveys. It's used whenever you're trying to create a population, right? So if you're trying to survey the whole population of Texas, you can't do that. We got too many people. Texas is too big, right? So you need a random sample of the population of Texas, right, to survey. So you've got to have some young people in there. You got to have some old people in there. You've got to have some male, female, right? You've got to have all of these different people in there. So you'd use random sampling to do that. But random assignment is going to be used in experiments. That's where we randomly put people in that either experiment group or the control group. So random sampling is used for surveys, sampling, survey, and then random assignment, like you're assigning people to groups, is used for experiments. And then we want to make sure that we always replicate experiments, because sometimes the experiment can come out statistically significant, but if you do it again, it doesn't. And so you need to make sure that you do it over and over and over and over and over and over again to get the same results each time. So, forgot I put pictures of myself in here. We always need to have operational definitions. For some reason, this is the thing that like disappears from your mind, and I don't know why, but you just have to really define what the variables are, right? So if you're using the cookie situation, you'd have to define what kind of cookie, right? Because if I use chocolate chip, but someone else use oatmeal raisin, that could be a confounding variable. So you need to give it an operational definition so I can replicate it exactly. And you need to do that for the dependent variable as well. So if you just said like higher test scores, it would need to be like a range, like are we moving from 80 to 85 or 80 to 81, right? You just need to be so specific. So if you get an FRQ prompt that says, hey, what are the operational definitions for the independent variable and dependent variable? You just have to describe them specifically so someone else can replicate the experiment. Now, this is the super fun part where you're like, oh my gosh, statistics. So you have to test to see if something is statistically significant, right? And we do that with the p-value. Now, the really cool thing about Psych is you don't have to ever calculate this. It's just given to you, and you have to know, okay, what do I do with that, right? So your p-value, it can't be any greater than 5%. It needs to be less than that. If it's less than 5%, then it's statistically significant, right? But if it's more than that, we can't say that our results are significant, and we can only say that they are due to something else. And so we want the p-value to be low so we can have that cause and effect relationship between the independent variable and dependent variable. So just really make sure that you know what the p-value is. It's the likelihood that the result is due to chance, right? So if you have a low p-value, then the result is not likely due to chance, which is good. That's what we want. But if the p-value is high, then your results are due to chance, and that's not significant, right? So maybe go back and read over this slide, read over that part in the textbook if you're still a little bit confused by that. And then we have different parts of statistics. Okay, so you're going to have, we can measure things by central tendency, where we're looking at those numbers just kind of in the middle there, right? We can calculate the mean, median, and mode. I'm not going to go over that because I think we're pretty solid on that, but those are always central tendencies. And then you can also calculate variation. And so that's where we use range and standard deviation. Now, you should be pretty solid with standard deviation. Remember, standard deviation is just how far something is from the mean. And the normal curve is really, really, really good for that. So if you're looking at your normal curve, which we have on the slide right here, remember the mean is always going to go in the middle of that normal curve. Okay, and then your standard deviation is going to tell you how far things are away from the mean. So if you have your mean in the middle, and we're going 1 standard deviation above the mean, right? That's this line right here. And if we're going 2 above the mean, then that's this line right here. 3, that's this line. And so usually we just go 3 above, 3 below. And you want to make sure that you know the percentages that go along with that as well. 68, 95, and 99.7. Again, those are rounded. So if you're in AP Stat, it might be a little bit more precise than this. We know that standard deviation is the variance squared. So if you have a variance of 100 and they say, hey, find the standard deviation, you just have to take the square root of 100, which would be 10, and then your standard deviation would be 10. Hopefully that makes sense. So again, if some of this stuff is like really confusing to you, let me know, but I think you understand it pretty well. You just need to go back and review it because we haven't talked about this since like September, and a lot has happened since then. So make sure you're looking back over your notes for research methods. Make sure you're looking through that textbook. This is a really good time to look through that and maybe read some of the chapters that you didn't do very well on the test in, and just kind of gain that extra information. But yeah, we really, really, really want to make sure that we know our research methods because I'm pretty sure that's going to be part of your FRQ on the AP test. It usually always is. I know it's crazy, but I would still count on it. So email me if you have any questions. But yeah, if you're deciding what to review, make sure that you are reviewing research methods a lot more than history and approaches, because like I said, they're probably not going to talk to you about that, and you've seen those perspectives so much already throughout the year. You really, really, really want to focus your time on research methods. So I'll see if I can find some online practice for us, figure out how to do that over Google Classroom. But if you're going through, you're highlighting, adding things to your notes, watching this video, refreshing your mind, I really think that you're going to be fine. So yeah, let me know if you have any questions. Get outside today, text a friend, see how they're doing, and I will talk to you soon. Bye.